In today's lesson, we are going to talk about the method of undetermined coefficients for the systems of differential equations. So, the general problem here, consider that we are given the non-homogeneous different systems of differential equations. Here, x of t is vector A matrix and f of t is also vector. The general solution of this non-homogeneous system can be found as a sum of the general solution of the corresponding homogeneous system and a particular solution of the non-homogeneous system. There are several methods to solve this kind of systems, and one of the most important methods is the method of undetermined coefficients. So, let's look at the problem. So consider we are given the homogeneous system, the first one. And the second one is non-homogeneous system. Because f of t, there is f of t, is, which is not equal to 0. If f of t, the function f of t, is equal to 0 plus a1t plus a2 squared plus and so on n t to the power of n, or e to the power of alpha t, or cosine beta t, or sine beta t, or some combinations of these functions, we can find the particular solution of the non-homogeneous system using the method of the undetermined coefficients. There are two cases. First, we're going to look at the first case. So, if f of t equals p m t e to the power of alpha t, here p and t is polynomial of degree n. If f of t equals pm of t e to the power of alpha t, we can find the we can find the particular solution as the form of this. X of t is p of t equals who m plus s k t e to the power of alpha t. Here, q is also a polynomial of degree n plus s, and s and if alpha is not the root of characteristic equation, then s equals 0. If alpha is the if alpha is the root of the characteristic equation, then s we can here we take the s the multiplicity of the alpha. Case number 2. If f of t equals e to the power of alpha t and pm of t cosine beta t plus qm of t times beta t, we can find the particular solution of the non-homogeneous system as the form of x particular of t equals e alpha t m l plus s t cosine beta t plus n l plus s of t times beta t. Here L equals maximum of m and n. And one more thing, if alpha plus e beta is the root of the characteristic equation, then s is the multiplicity of this root. If alpha plus b beta is not the root of the characteristic equation, s equals 0. Let's look at an example. y plus e to the power of t. Y prime equals x plus e to the power of 2t. First, we have to find the solutions of the homogeneous part, which is x prime equals y prime equals x. I'll write the matrix, A matrix 0, because there is no x in the first equation, and 1, and 1, and also 0. And I'm going to write the characteristic equation. We can find the characteristic equation using the matrix A. Determinant A minus E equals minus lambda 1 equals the square root times 1 equals 0. And here, I have 1 equals 1 and the other 2 equals minus 1. So we can write the general solution of the particular non-homogeneous system as the following form. Using these characteristic numbers, we can find the general solution of the homogeneous system. X equals 1 e to the power of t plus c2 e to the power of minus t. And y equals c1 e to the power of t plus c2 minus c2 e to the power of minus t. This is a solution of this part of the system. And we have to consider the second part, which is the f of t. E to the power of t is equal to e to the power of 1 t. And here we can find alpha equals 1. And 1 is the solution of the characteristic equation. So we have found s not equal to 0 is equal to 1. So we have to consider the particular solution of the non-homogeneous system. X particular of t equals P1 of t, P1 of t, e to the power of t. Here, P1 of t equals a plus bt. And we consider this is a plus bt and y equals c plus dt. We take this expressions, we put these expressions into this equation, and doing this we can find the constant numbers a, b, c, d. If we put these expressions into the system, we can find the constant numbers a, b, c, d. And the solution of the non-homogeneous system, a particular solution of the system, is this one. So the general solution of the homogeneous system can be written as x of t equals x solution of the homogeneous system and x particular. So here we can find x equals c1 e to the power of t plus c2 e to the power of minus t plus t e to the power of t, and y equals 1 e to the power of t minus c2 e to the power of minus t plus t plus 1 e to the this is the solution.